Good evening, everyone. So today, let's look at the PNG file format. PNG file format, a beautiful, simple format. So this is a poster I made ages ago about the PNG file format that you may know of. So it's available on my GitHub, github.com/korkami/pix. And tonight we'll just analyze another PNG file. And you can hardly see it. It's only 3 pixels, but it's simple and there is enough to say about the PNG file formats. So hi everyone. And yeah, let's go through the PNG file format. And what I like about the PNG file format is start with a very interesting thing. So first of all, the PNG file formats has a very simple structure, like the simplest of all, a signature, then a sequence of chunks, and the chunks have a very well-defined structure. So yeah, so it's a beautifully elegant and simple format. So you could say there's not much to say, which is why we can go to it in detail. And the PNG file format starts very interesting from the very first byte. Because, I mean, okay, it starts with a signature that is 8 byte. So the byte is technically called, what is it called? Where is it? In Octal, it's sad that the official definition is completely hiding the interesting part of the meaning of the signature. And even in this book, it's not completely detailed. So which is why I'm gonna enjoy detailing the signature, because it's pretty elegant. So the signature is like 89, and okay, let's see in the hex editor. No, not this one. Sorry. Okay, let's go for another file. Where is it? Yes. So in X 89, 50, 4E, 470D, I mean, you see it here, right? And suddenly it looks in hex and it could have no meaning, but actually it has a lot of meaning. And the first interesting part of the first byte is that it starts with a byte that is, so if you know your ASCII table, the ASCII table is made like this. You have the first 32 bytes, the first 2 rows are made of control code, which are non-printable. Then you have up to from 20 to 7E, you have the printable characters, okay? And then this is what is defined in ASCII. And the rest is defined via code pages. So from 80 to FF is defined in code pages. So basically, and these files too, you can find them on my GitHub, right? So here is an example of code pages. Oh, this is not the file I wanted to show you. This is the DOS code, the standard DOS code page. So you see the definition from 80 to FF, but also there are other code pages. Do I have them here? No, did I screw up my preparation? Tac. Okay, it should be somewhere around here, another place. Okay. So nope, code page. Okay, I thought I put them somewhere. Okay, never mind. Anyway, the code pages will change depending if it's code page for Russia and it's for, I mean, it's even better to actually look for it on my GitHub so that you will have a walkthrough, you know? So you click on my GitHub, binary posters, and then char set and encoding, and here are different code pages of other formats. So this one, there is Greek. This one has the Greek characters. This one is the Windows code page, and this one is Central European. So yeah, I recognize. Are there some Polish letters? Yes. Yeah, exactly. And I also like the KOI8R, the Russian one, because it matches via the highest bit Cyrillic characters to ASCII. So by just flipping one bit, you kind of change the alphabet, and it's still kind of readable, but it makes sense that, oh, the bit is flipped wrong. I mean, the bit is wrong. And here, this is a bit what's happening, what's the interest of this signature. So it starts with 89, which is, again, not a ASCII and printable character. So if this file is going to be transmitted as ASCII and have the highest bit stripped, then the 89 should not happen in the most standard file, but it will become a 09, and the 09 is a tab. The 09 is a tab. Where is it? Horizontal tab. And basically, if you take a PNG and when you cut it, and instead of 89 you have a 09, that will be a tab which will be clearly visible because you will see a tabulation, like a lot of space just before the PNG. So 09 is a very perfect character to see once the bit has been removed. Therefore 89 is a very interesting character to set first into the first in the first byte of the file. And to be honest, it's also okay. This was used for MNG, APNG, and JNG, which is JPEG-based PNG, which is quite rare. I mean, very rare. But it's no surprise that this format was actually used for other formats. So if we take RGB file, so I mean that's a PNG. So you see the signature here. 89, blah, 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 blah. And it's no surprise that this same logic was imported to a format that has nothing to do with it, the HDF file format. And you see that they started the same logic of 89 as an identification character, and then the same logic behind it that we will cover a bit further now. So the HDF format is the hierarchical data format, which is maybe not known of you, but it starts with a signature that is very PNG-like to show you that it's a very clever style of signature. And now we're going to go further. So as you could understand, the first byte, so sorry, I'm going to see if there are questions, just in case. No questions, okay? So as you can see, the first byte is so 89. So again, a non-ASCII character extended code page, which would map back to 09. Then the 3 letters of the file type and the extension, which makes it very easy to identify. And then you have 4 other characters, which are a bit interesting too. So you have \r, \n, and then which is basically, so if you know again, let's go back to this table. So when you say control, you just go back from control R. Where's the logic? Sorry, I'm a bit lost myself. Anyway, new line. Yeah, new line. Oh, that's carry edge return and line feed. So basically, when this is \r/n is a Windows new line, \n is Linux new line, and so basically the presence of \r/n and also \n makes it very easy when by accident the file had its new line being converted from one standard to the other. So basically the signature, oh, and I forgot, of course, the 1A that is in the middle is actually mapped to Control Z, which is, so Control Z is called substitute as a control code, but in C it's treated as end of file. So basically that will the Control Z character is supposed to be detected as an end of file character by C standards. So basically all these characters, 89, \r/n, Control Z, so end of file in C, and new line in the Linux way. These are all interesting characters that were put there to easily detect if there were errors in the transmission of the file and what kind of errors. So it's only 8 bytes. It identifies the file format, but it's also very clever that around is surrounded with typical, I mean, very useful characters to make detection easier. So it's a lot of time spent on the signature, but to be honest, this one is quite magic. Best joke ever. Anyway, so now as I mentioned, the rest of the file is made of the sequence of chunk. Any questions so far? No questions so far. Okay. And now it's a sequence of chunk, and this file is of course extremely small. I mean, otherwise we would spend hours identifying it, but still it's a very standard PNG and very common. So again, the length of a chunk is made of a length, a type, some data that could be null, and a CRC32. And that could be null. Let's go directly at the end. the image end is a chunk itself, and it has a length of 0. The type is IN, so image end, and the data is indeed 0 of length 0, and there is a CRC32 of the whole thing. So basically, this shows you that the length is the length of the data itself, and even something like the image end is the terminator of the file is following the same chunk logic. Okay, and then so you have the length, and the length is treated as unsigned, but it shouldn't have it shouldn't be have its highest bit set anyway. I mean, yeah, you get the idea. Now, very interesting that is not visible here is that this image is minimal. So basically, it has only very important data, and basically all the chunks here are critical. And this is actually very interesting because the type looks like a 4-letter word. This is true, but the uppercase and lowercase is actually very important. And if the chunk, the first letter is uppercase, then the chunk is the first. It means, is it critical or is it secondary? Then the second bit, so if the second letter is public, is critical, means is it public or private? And the third one, okay, shouldn't be, okay. And the fourth byte is that should we keep it when we create a new file based on that one, and not on the other, and not if it's set, then it's safe to copy if it's uppercase. So here is the example from the specification, okay? And you see that a chunk with the lowercase first letter will be treated as secondary, ancillary, which means basically if you add a chunk that is called Ange with a lowercase a, then this will be ignored by the rest of the file. So the standard says that the first chunk should be image header, IHDR, but it's not exactly true. And most readers, most parsers actually don't care if there is another chunk that comes before, like you could have 000 Ange and another and a CRC32. And also, I should mention that most of the time, if the CRCs are invalid, it only triggers a warning at best. The file is not rejected. But in practice, I mean, in theory, the first chunk should be image header, but in practice, it's not, except by Apple viewers, as far as I know, especially because Apple decided to create their own standard of PNG. So let's go through a standard PNG again. And this is a standard PNG. And this is a CgBI PNG. And CgBI PNG basically are iPhone. So it stands for likely core graphics bitmap info. And you see that the first letter is uppercase C. So which means this chunk is critical. So like if you can't parse this file, you shouldn't parse any further and you should abort because this first letter is uppercase. And the CgBI is indeed quite standard. I mean, basically, it's not a RGBA file. It's just the other way around, BGRA with premultiplied alpha. I won't explain what that means, but basically, these are PNG files that are optimized to save a little bit on iPhone rendering, like to match a bit closer the hardware. And yeah, so CGBIs are non-standard, but it also shows that yes, there are some PNG in the wild. Oh yeah, and PNG you're supposed to be officially call it ping, but yeah, look, it's a PNG. So I mean, so PNG, it's like GIF and GIF. You have two pronunciation. Well, yeah, just for a remark, PNG or ping. So basically, most PNG anyway must start with image header as a first chunk. Any questions so far? No questions. Okay. So now, we always have the image header typically in first position, except in some of my crazy files, of course. And the content of the image header, the length of it is completely fixed. It's like there is no manipulation, there is no trick. And if you notice, there is no version number either. So basically, now it's pretty simple. There is a width on 4 bytes. And like most image file, the NDNS is big, so it's like human readable and not with the lowest number nibble first. So basically 3, 1, and then there is the bits per pixel. Okay, it depends if you want something grayscale, and if you want something, you get the idea. I mean, it's not very important here. The type means the color space. Basically, is it RGB, RGBA, paletted? It could have a palette, and then the colors would be not the components, but just an index in the palette. And then compression is always 0. It's always deflate. Deflate is the compression of zip. I mean, one of the compression of zip or gzip, but and actually it's not deflate. Sorry, it's strictly a zlib, and which is encapsulation of the deflate. Sorry for that. Actually, I made a separate presentation on making sure about the difference between zlib, deflate, and gzip, because sometimes it can be confusing, especially when you have some headers removed and so on. So deflate is the only compression that is supported. So this byte is always 0. Then filters and interlace define some post-processing of the data after the pixel values have been extracted. Nothing that I will cover here, but these values have very small ranges of possibilities, and they are well defined. There is no trick there that I'm aware of. And then there is a CRC of very likely the data, and if I recall correctly, also the type. But yeah, it's in the specs. The CRC is computed on blah blah blah. It's not that you get the idea. It's in the specs. Yeah. It's not clearly written. CRC, what's this? The CRC calculated on including chunk type field and the data, so not the size, as I imagine, because that wouldn't make much sense. Anyway, so this is the first chunk that we covered with content, and there's not much special, nothing special. It's always the same in size of the chunk data, and the values are very, very standard. I'm not aware of crazy dimensions. I mean, here the values are pretty enforced. Like if you put a completely crazy with the highest bit set, first they should be ignored, but in practice it's rejected. Unlike, for example, JPEG, I remember some JPEG scanners, how do you call that? Rolling scanners that could generate a very long JPEG of unknown height in advance. Then these scanners would generate image with a huge height, just to make sure, and actually parsers would be fine with it. As far as I know, PNG dimensions of an image are actually enforced, but the JPEG with a crazy dimension that is way bigger than the actual pixel data is something I saw in the wild, and I think it actually triggers false positives in the past with some exploit of detection, overlap of exploit with a huge dimension and standing scanner. I forgot the name. These scroller scanners, So yeah. So now the image data, the IDAT chunk. So again, all uppercase because this thing is critical, it's safe to copy, and as you could imagine, it's the image data, so the pixel data, and there's not much to say here. It's how can I say? It's just a zlib package containing the data, and here, if you see, I set the block to be stored in raw, which means the pixels will be stored exactly in clear text, and I color them. Before the pixels, you will have a filter value, which will be another way to tell the post-processing how to interpret this line. So so there is always an extra byte for each line of the graphic of the bitmap, and so that it's not pure pixel values. And this was actually, I think, a problem because it cannot have so complete crazy values. Um, so yeah, if you want to really do some complex abuse, you cannot directly put pixel values, but at least you can still store the pixel in raw blocks, but it will still be in deflate, which is encapsulated by zlib, which means there will be Adler 32 and also all these structures before. So it's not pure pixel data. I mean, a bit, for example, zip has the ability to use deflate in a similar way, but also has the ability to store data, in which case the data would be without any zlib or Adler 32 data information. But this is not the case here. PNG is always using zlib. But on the other hand, you could probably, I mean, that would be, I'm not sure if it's possible, but you could very likely do a polyglot of zlib and something else, maybe zip, I don't know. I haven't tried it myself, or maybe I don't remember trying, but you get the idea. So that's all for now. And how much time are we in? Uh, yeah, okay, 20 minutes. How do you have any questions? No questions. Okay. So now let's just because we have plenty of time. I mean, we still have some time, and there are not so many possibilities, but it's worth covering here now. Yeah. Um, so the PNG format enforces the magic at offset 0, and it has a very good, it has a very strong magic. So especially with the 89 and the control Z, the 1A, very low chances of false positive over something like a HTML source or anything. So it's a good signature. It doesn't have any null character or anything, but still it's a very strong signature. And usually in a text file, you wouldn't have both \r, but I mean line feed character return mixed in that way. So the signature is very strong, and the signature is strictly enforced at offset 0. So that makes the ability of tricking any parsers absent. Then the length is actually checked. It's not. I'm not aware, but that could be wrong. But it might be a possibility that the image header length is hard coded because it's always the same. So there might be some parsers that just say it's 0D anyway, a bit like happens for BMP, for example, and if I recall correctly. And basically, you could have some 4 bytes that you could manipulate, but as far as I know, that's not the case. And then you could have, as I said, you could insert another chunk. So, for example, of course, you can do it manually. This is very easy, but you can also use a small tool like. Do I have it here? Yes. Tweak PNG is a very nice tool um, to modify a file interactively. So Twig PNG shows the structure of a PNG, and it has a good chunk of option, haha. And for example, these are the standard chunks that it supports. And so you see that some have a lowercase a, and some are critical. And a virtual page, I'm not familiar with that one. Stereo image indicator, there are more than that because you could create your own anyway. And if you open it here, it doesn't have the option to add one. But if you open Apple CgBI file, you will see it has iPhone-like PDF file header. So by deleting this chunk, you would turn it into a valid PNG, but the order of the pixel is not correct. So it might still not be valid, but at least that could be parsed. But you get the idea. Now, if I take back my file, okay, I hope you didn't get this in your headphones like I did. Uh, what did I want to say? Yeah, let's insert. Can I insert a dummy chunk? I don't know. Can I remove that chunk? No, I can't. Oh, come on. Edit chunk? No, I cannot. Okay. But anyway, so you know what? Let's do it ourselves. So we open our RGB file, and I'm going to be Ange. And now if I go here, I want to insert how many? Uh, 3 bytes, 4 bytes of size, 4 bytes of type, 4 bytes of CRC32, and some raw data. So let's say, yeah, another 4 bytes. So I want to insert 16 bytes of random stuff, and I will answer 10. This chunk I will call it Ange, because why not? Oh, sorry. And then I said I would put 10 bytes of data, so I miscalculated. So it's not 10 bytes of data. It's, I have four, oh no, sorry, image header is here. So now 4 bytes, that's the CRC, that's 4 length. And now, so I have only 4 bytes of length, and I'll edit that. So now I added a chunk of size 4. The CRC is invalid. And so a length of 4, a fake ID of Ange, and a dump, because that's the content of my data, or I could call it data. Why not? Let's be more polite. And then that's my CRC, which could be, sorry. Now, this is, I added my chunk, and the file will very likely, I mean, hopefully, will still work. Just because very few readers, even if the CRC is invalid, you know. So now you see that when I open with Tweak PNG, it shows me a warning saying, "Hey, invalid chunk," but it's just a warning, and that you could just insert this value. It's easy to compute and add yourself, you know. And the file is unrecognized chunk, but I mean, and so you see what I mean? I just created a dummy chunk with whatever other name. It's ignored by parsers. The CRC is not even valid. I mean, I could fix it. That's no problem. And here I disrespect a rule, a specification rule, to that the image header chunk should be first, but it works. So as you can see, it's very, very easy to add an unlimited amount of, I mean, especially because you could have, like, the length is on 4 bytes, you could have a huge chunk of data, and you could have as many dummy chunks as you want. They will just be skipped as long as the type is not recognized and the first letter is lowercase. So as you can see, very easy to identify, to add payload, to add whatever arbitrary data you want, you know, and to make it, you know, like as you see, making a JavaScript or PHP and PNG polyglot would be trivial. And now the last element of abuse that is very common is if since there is a very strong terminator, like if you notice, the terminator is super long, so 4 bytes of length, which is set to 0, 4 bytes of image and an uppercase, and 4 bytes of this CRC, always the same value. That's a 12-byte long terminator, which is constant. It's like a very, very strong identification of a CRC, of an image. And so basically, whatever you put here will be just ignored by anything. So as you see, if you need to put something after the image end, it's no problem, which is exactly why, if I recall correctly, in the wild, some people were appending, and you see that a small PNG is very close, is very short, you know. This PNG is still valid, and it's already like very small. How big is it? It's oh, sorry, this PNG is 94 bytes, which is like super small. So basically, but it's still a valid file, and it's a standard file type. So basically, if you append whatever you want, like ebooks or movies or whatever, next to a PNG, MP3, after a PNG or a zip, all the readers will say this is, all the parsers will say this is a PNG. the file is valid, the file is complete, or there is appended data, but maybe no time to check. And then you can piggyback and on it and actually leak some information or hide some information in a very easy way. There is no verification of whatever you put after the PNG terminator, the image and chunk. So I spent a few more. I spent a few more. I spent a few more time on the tricks of a PNG, but that's about it. Another trick that we used in the past and we used in a talk was to have two different palettes, and some parsers would, it's illegal to have two palettes chunk in the same file, and you craft an image to merge two images with different palettes, but that's a minor case specific parser image bypass, but it's not very standard, and it's just a, yeah, chunk duplicity could be a trick, could be a thing. And finally, maybe one more detail: the image dot chunk is if it's split, then every chunk is decompressed and concatenated, which enabled people to do parallel decoding, so multi-thread decompression of PNG by chunking the image in various image dead chunk, and they all decompress in parallel. But there could be some risks, which led David Buchanan, Retroid, to make a PNG that would work only on that would render differently on Apple and on other systems. So Hello World, he made a Hello World image that would display a Mac or IBM PC, depending on the OS you open it on, based on tricks with multi-thread decompression in the in PNG files. So I think I covered all the things that I remembered about PNG for now. And yeah, any further questions? Now I did two streams in one: the file, the PNG basics and the PNG tricks. And yes, if no questions, then I hope you had a good time. And thanks for your attention. And I guess see you next stream, most likely tomorrow. Thank you. Thanks a lot, everyone. And yeah, thanks for your attention. Thanks again. Thanks for your comments, guys or peeps.